Let's graph a polar equation. Here we're given r is equal to 1 plus the sine of theta. And remember, in polar coordinates, we're looking for ordered pairs of the form r comma theta. It's a good suggestion here, since we have r in terms of theta, to plug in theta values or angle values and then come up with the radii. So let's start at 0 degrees. I like working in degrees here. When we plug in 0 degrees into the sine, we get a radius of 1. 1 plus the sine of 0 is simply 1. So we have the point here of 1 comma 0 degrees. In a similar fashion, let's plug in 30 degrees. We have r is equal to 1 plus the sine of 30 degrees. We know to be 1/2, so 1 plus 1/2 is 1 1/2. And I'm going to write that as a decimal here, 1.5. So at 30 degrees, here's 1. This would be our point, 1 1/2. 45 in a similar nature, plugging that angle in, we get 1 plus the sine of 45. This is approximately 1.71. So at 45 degrees, here's 1 1/2, 1.7, right in this general area. Go with 60 degrees now. We're going to have 1 plus the sine of 60. This is going to be approximately 1.87. So at 60 degrees, we're going to go out here 1.87, getting pretty close to 2 out here. And we can plot a big point. You'll make sure and hit it. Now plug in 90. If we take 1 plus the sine of 90, we know that the sine of 90 is 1, so 1 plus 1 will give us 2, and we can plug in our 2. So that's technically the ordered pair 2 comma 90 degrees, even though it seems as we're working in reverse here. Okay, now an interesting thing happens here once we cross over 90 if we look at the angle right here, which is 120. Remember that the sine value of 60 degrees and 120 are the same, remembering that the sine is positive in both quadrants 1 and 2. So what we can do here is cheat a little bit, knowing that we'll have a similar ordered pair for 120 degrees. So it would technically be approximately 1.87 comma 120, but we can see that this graph mirrors itself in certain respects due to the nature of the sine. In a similar fashion, 45 degrees is related to 135 degrees. And so in addition, we're going to have the ordered pair approximately 1.75 and 135 degrees. So it's about just under halfway between those two circles. And we keep going here in the way that 30 relates to 150 across here. So we'll have the ordered pair 1.5 comma 150. So let me write that in here. And so that will give us the point here out at 150. We're out here at 1 1/2. So it's a good little trick working our way around here. Okay, so we've worked so far to here. Now let's look at 180 degrees. When we're at 180 degrees, we know we have a value of 1. So that's another point that mirrors across. And you can tie that in here with 0 degrees and our 180. So two sets of ordered pairs, 1 comma 0, so on and so forth. And then if you cover up this column, 1, 180, 1.5, 150, so on and so forth, gives us this nice shape of our graph. Now let's move into the third quadrant. When we're down here at 210, we're going to have r is equal to 1 plus the sine of 210. That's going to give us a smaller value of 0.5 here. So that's half the distance of 1, so we're looking at a point something like that. When we get to 225, we're going to have an approximate number of 0.293. So that's just about a third in here, and it gets a little bit tough to tell, but that's on the axis right there, and we're going to keep working our way in. When we get to 240, it's going to be approximately 0.134, and you get the idea as we're squeezing in here. And finally, once we reach 270 degrees, we're looking at a value of 0. So let's try and write this in here a little bit nicer. So 0, 270, this is the ordered pair 0, 270. And as before, the sign we know to be negative in both quadrants 3 and 4. There's this relationship across the axes. So I'm going to draw those in quickly since we hammered that concept earlier. And then try and draw our nice graph here. We started at 1 comma 0, drawing what's known as a cardioid all the way around. Keep going here. Tie this in And we have our nice graph. So it takes some doing. You have to be very careful. Using some of our attributes of the sine, we can see this mirror image. So we've graphed the equation, the polar equation, r is equal to 1 plus the sine of theta.